Okay, let's get one thing straight right from the start. Hiring tests, by their very design, are meant to discriminate. I mean, they have to, right? The whole point is to sort through candidates and find the ones who have the best shot at succeeding. But where's the line? When does that necessary discrimination become just plain unfair?
And this right here, this is the heart of it all. This idea from Robert Guion, all the way back in 1966, perfectly captures the core question we're digging into today. It's the gold standard, really, for figuring out if a hiring process is truly fair.
So here's how we're going to break it all down. First, we'll get into why these tests exist in the first place. That's the discrimination dilemma. Then we'll build our fairness toolkit so you know all the key terms. After that, things get really interesting with a major twist in the research. Then we'll look at how companies try to balance everything. And finally, we'll jump into the new frontier, AI and hiring. All right, first up, let's tackle this foundational truth. A good test has to discriminate. I know that sounds bad, but its job is to separate candidates who are likely to do well from those who, well, aren't. The real issue, the one we're obsessed with, is when does that sorting process become unfair discrimination?
Okay, to really get a handle on this whole debate, we've got to get on the same page with some key ideas. Think of this next part as us building a toolkit so we can properly dissect this thing.
And this right here is a super important split that people mix up all the time. On one side, you have fairness. That's a social idea. You know, it's squishy. What feels fair to you might not feel fair to the company. But on the other side, you have test bias. This is a technical, scientific term with a really clear statistical definition that we can actually go out and measure.
So that leads us right into this big concept, adverse impact. When you see this, it's a huge red flag, legally and ethically. It doesn't automatically prove a test is biased, but it's a giant blinking light telling us we need to investigate. And there's a specific rule used to spot it.
And that specific rule, it all comes down to this number, 80%. It's also known as the 4/5 rule, and it's the go-to guideline that regulators use to see if adverse impact might be happening.
So here's how it works in plain English. You look at the group with the highest hiring rate. Then you check every other group. If any group's hiring rate is less than 80% or 4/5 of that top rate, boom, you've got potential adverse impact. So if you hire 20% of male applicants, you need to be hiring at least 16% of female applicants to stay above that 80% threshold.
Okay, now we're getting into the real nitty-gritty of test bias. This is called differential prediction. Basically, it asks, is the test's crystal ball cloudy for certain groups of people? If a score of, say, 85 means rockstar employee for one group, but that same score consistently over or underestimates how well someone from another group will do, then the test has predictive bias. It's not just sorting people, it's getting the future wrong for an entire subgroup.
All right, so we've got our toolkit. Now, this is where the story takes a really fascinating turn. For decades, it seemed like the science was settled on test bias. But as it turns out, new research came along and flipped the whole debate completely on its head.
You know, for the longest time, the overwhelming consensus from study after study was that standardized tests were basically fair. And if there was any bias, it actually seemed to favor minority groups by slightly over-predicting how well they do on the job. So the test scores suggested they'd perform even better than they actually did. But then, a new generation of researchers started asking a really uncomfortable question. What if the reason we never found any bias was because the tools we were using to look for it were broken?
And it turns out the old ways of checking for bias had some serious problems. A lot of those early studies just weren't powerful enough to detect a real effect if it was there. The sample sizes for minority groups were often way too small to say anything for sure. And on top of that, all sorts of weird statistical quirks could have been hiding the bias or even creating the illusion that everything was fine.
And all this new digging led to a pretty mind-blowing discovery. Researchers found something they call a lack of differential prediction generalization. Now, that's a mouthful, but what it means is simple and revolutionary. A test isn't just biased or unbiased. Its bias can actually change depending on where and how it's used.
This chart just lays it out perfectly. You could take the exact same test and give it at 3 different companies. At company A, it might actually be biased against a certain group, underpredicting how well they'll do. At company B, it could be totally fair, no bias at all. And at company C, that same test might be biased in favor of that group. The takeaway is huge. Bias isn't just in the test, it's in the interaction between the test and the specific job context.
So, okay, given that this is way more complicated than we thought, what are companies supposed to do? How do you actually navigate this tension between hiring the top performers and making sure you're being fair to everyone?
Well, one tool, and it's a bit of a hot topic, is something called test score banding. The logic is that no test is perfect. So instead of pretending a 95 is worlds better than a 94, you create a band of scores and treat them all as basically the same. Then, for anyone inside that band, you can use other things to make a decision, like a commitment to diversity, for instance.
And this really lays bare the central tug of war for any company, right? Do you go with strict, top-down selection to try and squeeze out every last drop of performance? Or do you use a more flexible method, like banding, to balance performance with other really important goals, like building a more diverse and representative team? There's a real trade-off there.
All right, so now let's throw a huge wrench into all of this. Artificial intelligence. All these classic problems of bias and fairness are now being put on steroids as we hand over more and more hiring decisions to algorithms.
And when we're talking about AI, it's so important to understand that people are looking at fairness in two different ways. There's procedural fairness, was the how fair, was the process transparent, and then there's distributive fairness, was the what fair, did the right person get the job in the end?
And this is exactly where AI starts to feel, well, a little creepy to job applicants. Even if an algorithm is technically perfect and unbiased, people often see it as less fair. They hate the lack of communication, feeling like they're just a number in a system. And they have this deep fear that the AI is just a black box that's been secretly programmed with all our old human biases anyway.
So, after all this, what's the big takeaway? It's that being for or against hiring tests is the wrong way to think about it. Tests are just tools. Like any tool, they can be used well or they can be used poorly. What really matters, what determines if they're fair, if they're useful, if they're even legal, is how they're used.
And that leaves us with the defining challenge for the future of hiring. It's one thing for us, humans, to argue about what's fair. We can understand context and nuance. But as we teach machines to make these incredibly important decisions for us, we face a much harder question. How do we actually teach an algorithm what it means to be fair? How do you code empathy, ethics, and justice?